So the reading check question of the day at the top of the heap was contributed by Maddie. Congratulations, Maddie, for the top voted question today. And the question is, how do I know whether to use the quadratic formula, the thing we're about to learn, versus when should I factor? So what we're going to do, what the quadratic formula is going to do for us, is it's going to give us more options to solve a quadratic equation than we had before. Because prior to the exam, we had the option to factor and split, right? The option that you just used when you solved the previous quadratic equation. So we had that option before. We're going to learn a new option today, the quadratic formula. And the question is, how do we know when to use which one? And just to kind of complete this picture, here's my suggestion. The good news is the quadratic formula always will work, no matter what. There's no possibility for it to fail. It solves the entire class of quadratic equations all at once. So it's always an option. But when it typically gets used, so I'll put the quadratic formula down here in this box. When it typically gets used is when factoring doesn't work. Either because you haven't tried hard enough, or because it just plain there's no possible way to get it to work. So in my own process of trying to solve quadratic equations, I always try to factor first, because factoring, really the cognitive load is much lower, and you'll see why when we look at the quadratic formula in all of its gory detail in a minute. It's just an easier process for your brain to conceptualize. If the sum and product game has a winner, as it did in the examples that you just worked, then it is the shorter path to get to your solutions. That's why I like to try to factor first. But if factoring doesn't work, or if you just don't want to put in the effort to think about factoring, the quadratic formula is always an option. Then you also have to make sure you remember the quadratic formula appropriately, which is a whole other ballgame. But let's resume by thinking of that second equation, the one that the wall side of the classroom solved, which was x squared minus x equals 90. And so, just like with the other example, you took and subtracted 90 from both sides so that one side of this equation is turned into 0. Always the first step in solving an equation involving a polynomial. We can't do anything until one side is equal to 0. So x squared minus x minus 90 equals 0. And that 0, again, I'm going to think of it like it's a green light. It's a green light to do something. It's a green light that we can apply some sort of technique to solving this equation. Whether it be factoring or whether it be something else, now is the time to put that strategy into practice. So what we have is a formula. And it's funny how mathematicians use words. A formula is something that looks like an equation, but it's not really the same thing. A formula is always seen as a tool, whereas an equation is something that has a truth value attached to it. X plus 6 equals 0. That's an equation because it tells us that this is a true statement when x equals negative 6. But a formula is a tool for plugging numbers into. Really, it's one way of thinking about what a formula is. And so the quadratic formula is going to be a formula. It looks like an equation, but what it will do for us is it'll give us a template that we can plug numbers into, and then our algebra problem becomes an arithmetic problem, which is always a good trade-off if you can make it, right? Just by evaluating the quadratic formula after plugging numbers into it, we will find the solutions of this equation will just fall right out of it. Right? So here's how it works. The quadratic formula says that if I'm solving the equation, and let me write it out longhand here, A, B, and C equals 0. And so the quadratic formula begins with an equation that we're trying to solve. ax squared plus bx plus c is equal to 0. That a, the coefficient in front of the x squared, we require that a is not 0. Because if a is 0, then this term isn't even there at all, and we just have a linear equation, and those we can't solve with this formula. So we just have to make sure that the coefficient in front of the x squared is non-zero. so that we legitimately do have a second-degree polynomial on the left-hand side. And here's what the formula says. Formula says that the values of x which solve this equation are given by the following. First of all, it's a huge fraction. It's one big quantity divided by another quantity. So a giant fraction bar. And on the top of this fraction is an expression with two terms, the first term of which is minus b. So by the way, when I read this as minus b, not as negative b. If you pronounce it as negative, you will occasionally run into confusion. Minus b. Or the opposite of b, if you like, which means if b is negative, this number is positive. Right? If b is positive, this number is negative. So it's just the opposite of b, or minus b. That's the first term. The second term involves a square root, which is an animal that we haven't talked about much in our class yet. This is going to be an occasion for us to do so. So it's got this big square root sign here. And underneath the square root is a very meaningful quantity, and we'll talk about why in just a minute. But the quantity underneath the square root is another expression with two terms, and the first term of it is b squared. So whatever b is, we're going to square it. The second term is a term with three factors. The first factor is the number 4. The second factor is a, and the third factor is c. And so this quantity underneath the radical, b squared minus 4ac, according to the order of operations, we have to finish simplifying it, and then we'll take its square root. And that forms the second term on the top of the quadratic formula fraction. In between these terms is not a plus sign and not a minus sign, but rather a sign that combines the two of them together, which is, this may be the only place that you see it in a beginning algebra class. So this is a plus or minus symbol, and that causes little confusion when you see it for the first time. It just means that one answer is going to use the plus, and the other answer uses the minus. In other words, that symbol is how we're going to get two different solutions out of a single formula. That's the only reason that it's there, right? Is it gives us two different answers out of one formula. One answer that we get when we choose the plus sign and make it minus b plus the square root of b squared minus 4ac. The other answer that we get when we choose the minus sign and make it minus b minus the square root of b squared minus 4ac. So every time we see that plus or minus, we're going to end up splitting into two possibilities, one possibility with a plus, the other possibility with a minus. And that makes up the entire numerator of this fraction. And the denominator, luckily, only has a single term, and that term is 2 times a. And that's the quadratic formula. There are a wide variety of mnemonic devices and songs and you name it for helping people to memorize the quadratic formula that are out there. I should have assigned a song in the reading check. I missed my opportunity. But feel free. There are probably dozens of them out there on YouTube. So, complicated formula, and maybe one of the only things worth memorizing in all of algebra. Because of its flexibility, its versatility, this formula always works to solve a quadratic equation, provided that you've done the work of getting 0 on the other side first. How do we apply this formula to solve the equation that we started working on? We're working on the left, x squared minus x minus 90 equals 0. What do you want to do first to figure out how this formula can be used as a tool? What do we need to do? Exactly. A tool is only as useful as its operating manual, its instruction manual, right? And the instruction manual for this formula says we need to know what A, B, and C are so that we can plug them into this formula, right? So if we don't know what A, B, and C are, this tool is completely useless. So let's go to our equation that we're trying to solve and figure out what relationship it bears to this generic equation that the quadratic formula solves. In other words, what are playing the roles of A, B, and C? So for our quadratic, what's A? 1. And why is it 1? Where do you see the 1 in this? In front of the x squared. There we go. So the role of a is always that which is in front of the x squared, the numerical coefficient of x squared. That's what a is. Regardless of where we find the x squared term in our expression, right? I could rearrange these terms if I wanted to, but a would still be that 1 in front of the x squared. So here in this example, a is equal to 1. So I'm actually going to take, and down in our little template, I'm going to fill that in. 1. And then in place of the a up here, I'm also going to put in 1. All right. So you've identified that a is equal to 1. How about b?
-1.
Why is it -1? Where are you finding -1 here? Yeah, so there's a 1 in front of this x, but there's not just a 1 in front of this x, because that x has been subtracted from the term that comes before it. So -1, because the x term in our quadratic expression on the left-hand side has a coefficient of -1.
Can you just, sorry, I wasn't.
And paying very close attention to signs is going to mean replacing this b with a -1. And then it's exactly what you just said happens, right? If I replace b with -1, then this term that's out in the front becomes minus -1, which is otherwise known as 1. So minus b is positive 1. And then another common source of sign errors is we're going to end up having to also square that b, -1, the quantity squared. And so we'll have to worry about that in a minute also. But for now, I'm just going to leave that sit until we've talked about c also. Because what is c in this example? -90. C stands for constant, if you like. It's the term that has no x in it in our quadratic expression on the left-hand side. And so c is -90. And so in my formula, in my little template, I'm going to multiply by -90 over here, where we used to have a c. And again, when I talk about sign errors, there are so many possible places to have a sign error. We already talked about this 1 out here in the front because it was minus -1. But this squaring that we're going to do right here, potential to lose a negative sign, but probably the most common place for people to make sign errors is actually right here in this part of the expression. Because what we're going to end up having to do next is multiply 4 times 1 times -90. Well, I guess we have to do the squaring first. But when we multiply 4 times 1 times -90, we're going to get a negative product, which we then have to subtract. Right? So this clutter of negative signs is where most people screw up in evaluating the quadratic formula. So just take extra time and extra care when you're working with these expressions, because it is so easy to be led astray. But when I say the quadratic formula takes an algebra problem and it turns it into arithmetic, that's because all we have to do now to finish this problem is just to evaluate this numerical expression that's over here on the right. It's just an order of operations thing. We don't have to solve for x. We don't have to work on both sides of an equation. We don't have to do any of those algebra things. We just have to do the arithmetic. And that means following the order of operations. So what do you want to do first in this clutter of expressions? Yeah, first of all, the square root sign here, this radical, is grouping the terms underneath it together. So it acts kind of like a set of parentheses. So let's use that to focus our attention on what's underneath the square root first. We'll worry about it, then we'll take its square root, and then we'll worry about the rest. So underneath the radical, we've got -1 squared minus 4 times 1 times -90. In that expression, what do you want to do first? What does the order of operations say? Yeah. So according to the order of operations, we should square -1 first. What is -1 squared when it's written with the parentheses like this? 1. Because it's -1 times -1. Okay? And now that the exponent has been exponented, what do I want to do with the rest of this expression? So we did the exponentiation. What comes next? multiply. 4 times 1 times negative 90. Negative 360. And when I say this is where people screw up negative signs, it's often because this minus a minus goes awry. Because what is 1 minus negative 360 really?
1 plus 360.
Yeah, I'm just going to turn this into a big plus sign. 1 plus 360. Okay, so after we did all that stuff underneath the radical, we come out with a number, 361. And that number is underneath our square root sign. And then we still have all the other stuff that makes up this expression. We have a 1, we have this plus or minus, and then on the denominator, we might as well simplify out that denominator. 2 times 1, that's 2. Okay. All right, so we simplified everything under the radical that we can simplify. We got a nice number, 361. Now, before we worry about the plus and minus, let's finish the square root. So now is when we get to pause and ask, what's the square root of 361? And how could we know what the square root of 361 is? 19, yeah. So the calculator actually is a really efficient way to do the square root. The square root of 361 is 19. Now remind me, what does that mean? Why should we expect that the square root of 361 is equal to 19? What is the square root actually doing? Or maybe, why is the square root of 361 equal to 19? Yeah, exactly. So all we're doing when we take a square root is we're undoing the operation of squaring, right? Square roots are to squaring like multiplication is to division, like addition is to subtraction, right? Square root of 361 is 19 because 19 times 19, or 19 squared, is 361. So a square root is just asking the question, what number multiplied by itself gives us 361? And thinking backwards in that way is not always an obvious thing how to do, which is why calculators really do make this a little bit easier. If you do memorize any square roots, just kind of restrict it to the small ones. The square roots up to 144, for example, which is 12 squared. Anything higher than that, have a calculator on hand for those occasions. So what we end up with is 1 plus or minus 19 divided by 2. And now we have to wrestle with that plus or minus. So what are we supposed to do with this plus and minus symbol? How do we get our answers out of that?
What you would do is it would be like 2 problems.
Okay.
It would be, you first do 1 plus 19, and then divide it by 2, and then 1 minus 19 divided by 2.
Okay, great. So it becomes 2 problems. Yeah, I like the way you phrased that. Even though it's one formula, that plus or minus symbol turns it into 2 different answers, 2 different problems. One problem where we choose the plus sign in that spot, and the other problem where we choose the minus sign in that spot. And then we just do the arithmetic that's necessary. 1 plus 19 over 2, that's 20 over 2. And what's 20 over 2 better known as? 10. So one of the solutions of the quadratic equation that we started with is x equals 10, which you all found doing it the factoring way. 1 minus 19 over 2. Well, what's 1 minus 19? This is another place where it's easy to screw up signs. So 1 minus 19 is negative 18. Negative 18 divided by 2 is negative 9. And so at the end of the day, there are those 2 solutions that those of you on the window side of the classroom found for this equation by factoring. So going back to Maddie's question, when do we want to factor? When do we want to use the quadratic formula? Well, we've done this problem, at least those of you on the Windows side, both ways. What do you think? Which way would you prefer to have done this problem?
The first one.
The first way, the factoring way? You like the factoring? Anyone prefer the quadratic formula? So there will always be a few people. If you prefer the quadratic formula, hey, great. Like I say, one of the benefits of this is that it always, always works. It's impossible to stump the quadratic formula. It is possible to stump you as a person trying to factor, right? So we're going to get some more practice with this in Monday's class. I've set aside Monday's class for continuing this conversation about the quadratic formula.